Welcome to the deep dive. Today we're getting airborne, you could say. We're exploring the fundamentals of helicopter flight maneuvers.
Yeah, absolutely. Think of it as like unlocking how these amazing machines actually move through the air.
We've got a great source for this, a chapter that really focuses on these core skills.
Right. And our mission really is to understand how pilots control helicopters during these basic fundamental moves. We're looking at the cyclic, collective, throttle, pedals, the whole setup.
The interplay between them all. And it's not just the controls in isolation, is it? We're also digging into how things like, well, wind affect things.
Exactly. And even touching on some common errors pilots might make, especially when learning.
Mhm.
And our source makes this really crucial point early on. Every helicopter is a bit different. Even two of the same model might handle slightly differently based on the day's conditions.
You mean like wind temperature?
Wind, temperature, humidity, weight, even the gear it's carrying. It's, a constantly changing picture up there.
Okay, so to get us started, the source lays out four fundamentals. These are like the building blocks for everything else.
Precisely. Everything, no matter how complex, builds on straight and level flight, turns, climbs, and descents. Master these, and you've got the foundation. It's like learning scales on an instrument before playing a symphony.
Right. Got to the basics down cold. So let's start with straight and level. Sounds simple enough, maybe deceptively so.
Definitely. It's all about holding a constant altitude and a constant heading. But the key is how the main controls work together.
Okay.
So the cyclic, that's your stick, that primarily controls your airspeed by tilting the whole rotor system, the tip path plane. Tilt it forward, you speed up. Tilt it back, you slow down. Simple concept, but
Tricky in practice, I bet. And altitude. That's the collective.
that's the collective lever, yeah. It changes the pitch, the angle of all the main rotor blades at once. More pitch, more lift, you climb. Less pitch, less lift, you descend.
But you can't just yank on it, right? There are other effects.
Spot on. Pulling collective demands more power, so you have to coordinate with the throttle to keep the rotor RPM steady. That's critical.
Okay, maintain that constant rotor speed.
Always. And then you've got the anti-torque pedals, the rudder pedals, essentially. They're constantly working to counteract the main rotor's torque, just to keep the helicopter pointing straight, keeping it in trim.
So let's paint a picture. If I want to climb but keep my speed the same, I'd ease up the collective
Right. Increase collective smoothly.
and adjust the throttle to keep the RPMs right, and maybe a little aft cyclic.
Exactly. A slight aft cyclic helps direct more of that rotor thrust upwards for the climb, while the collective increase provides the power. Conversely, to gain speed at the same altitude, you'd push the cyclic forward.
And probably add a touch of collective to compensate for the tilt.
You got it. It's this constant balancing act.
The source mentions a slight delay in the helicopter's response. That sounds crucial.
Oh, absolutely critical. Helicopters have inertia, especially in that big rotor system. They don't snap to attention instantly. You learn to anticipate, to lead your controls slightly.
I can see how new pilots might overcontrol then, chasing the aircraft.
Very common. The source points out helicopters are super maneuverable, controllable, but they aren't inherently stable like most airplanes. Bump it off course, and it tends to stay off course until you correct it.
So what are the typical trip-ups for straight and level?
Well, the source highlights a few. Not trimming properly is a big one, ends up with pilots cross-controlling, holding pedal against cyclic without realizing it just to stay straight.
Fighting the controls.
Yeah. Also, just not hitting the target airspeed or holding the ground track accurately. And another one is not letting the helicopter actually settle at a new airspeed, constantly fiddling.
Okay, makes sense. Let's change direction now. Let's talk turns. How do we get the helicopter to change heading?
Right. Turns. The fundamental action is applying sideways pressure on the cyclic stick.
Towards the direction you want to turn.
Exactly. That banks the helicopter, tilts the rotor disc sideways. A component of that lift now pulls you horizontally into the turn.
And the pedals, are they involved in starting the turn?
Crucial point here. And the source emphasizes this. Pedals are only for torque compensation, keeping the helicopter streamlined, in trim. You do not use pedals to initiate the turn itself.
Got it. Cyclic banks it, the bank causes the turn, and a steeper bank means a faster, tighter turn, generally.
That's the principle, yeah. Bank angle dictates rate and radius, but it's not just cyclic. When you bank, you lose some vertical lift.
So you need more collective to stay level.
Precisely. Increase collective, coordinate throttle for RPM, and adjust the anti-torque pedals because the torque changes with the power setting. You might even need a bit of forward cyclic in steeper turns to maintain airspeed.
Wow. It really is everything working together all the time. So to roll out, just opposite cyclic?
Opposite cyclic, yeah, but again, you have to anticipate. Start rolling out before you hit your desired heading because of that inertia. Lead the rollout.
And these basics apply if you're turning while climbing or descending too, right? Just combining techniques.
Exactly. You're just adding climb or descent inputs to the coordinated turn inputs.
Okay. Now, the source mentions slips and skids and turns. Sounds like something you want to avoid.
Definitely. A slip is when the helicopter is kind of sliding inwards towards the center of the turn. It feels like you're falling into the turn.
What causes that?
Usually it means you haven't used enough anti-torque pedal in the direction of the turn for the power you're using. Or maybe too much opposite pedal. The nose isn't quite following the turn correctly.
And a skid is the opposite, sliding outwards.
Correct. Skidding feels like you're being thrown out of the turn. It happens when you've used too much pedal into the turn, forcing the helicopter to yaw faster than the bank angle supports.
How do pilots tell if they're slipping or skidding? Visual cues.
Yeah, many helicopters have a simple yaw string on the windscreen. In a coordinated turn, it streams straight back. In a slip, it points inside the turn. In a skid, it points outside.
Or an inclinometer ball, right?
Same principle. The ball moves opposite to the string. So, skid, rate of turn too fast for the bank, slip. Rate of turn too slow for the bank, keep that ball centered or the string straight.
Got it. Okay, let's climb. Moving on to the next fundamental. Climbs and descents, starting with a normal climb from cruise.
Right. So to initiate a climb while holding your airspeed, you smoothly increase collective, add throttle to keep the RPMs pegged.
And coordinate pedals for trim, of course.
Always pedals. Then a gentle aft pressure on the cyclic. This tilts the rotor thrust slightly upward, giving you that lift for the climb without losing speed.
Right, using some of that forward thrust potential for vertical movement. The source mentioned the nose attitude isn't always a perfect indicator of climb or descent.
That's a really key point, especially compared to airplanes. A helicopter in a steady climb might have a nose attitude that looks very similar to level flight. It's more about where the power is directed. Acceleration and deceleration show up more obviously in pitch attitude.
What if you want to climb faster, but maybe at a slower airspeed?
Then you'd initiate more with aft cyclic to pitch the nose up, which slows you down and directs more power vertically. But as airspeed drops, especially in counterclockwise rotor systems, you'll need more left pedal because the tail fin becomes less effective.
Makes sense. And leveling off, how do you hit that target altitude smoothly?
Anticipation again. You need to start nudging the nose back towards the level flight attitude before you reach the altitude. Rule of thumb. Lead by about 10% of your climb rate.
So climbing at 500 feet per minute, start leveling about 50 feet below.
Exactly. Gradually apply forward cyclic. Keep the climb power in until your airspeed builds back up to cruise. Then reduce collective to your cruise setting. Adjust throttle. Trim with pedals. Smooth transition.
Common mistakes during climbs.
Letting the power or airspeed wander. Incorrect pedal input leading to slips or skids. And a big one on level off. Reducing power before getting the nose back to the level attitude. You can easily dip below your target altitude doing that.
Okay, now let's come down. Normal descents from cruise.
Pretty much the reverse process. Lower the collective smoothly to reduce lift and power. Adjust throttle for RPM.
And you'll need opposite pedal now, right? Right pedal usually for counterclockwise rotors as power decreases.
Typically, yes. Increase right pedal as you lower collective. Then, use the cyclic to set your desired airspeed in the descent. Forward cyclic to maintain or increase speed. Aft cyclic to slow down as you descend.
So the cyclic is directing that remaining lift and thrust vector.
Precisely. It's deciding how much of the rotor's effect goes into forward movement versus slowing the descent. And just like climbs, airspeed changes affect the tail fin, so you're making small pedal adjustments to stay trimmed.
Leveling off from a descent, same 10% lead principle.
Yep, same idea. Start leveling off before you hit the target altitude. Smoothly increase collective back to cruise power, adjust throttle, increase left pedal typically, and adjust cyclic for cruise airspeed and level attitude right as you reach the altitude.
Things to watch out for during descents.
Maintaining a steady descent angle is key for predictable approaches. Failing to lead the level off enough is common, ending up low. And again, forgetting those pedal adjustments as power changes. Easy to get sloppy with trim.
Okay, we've nailed the 4 fundamentals. Now for some specific helicopter-only stuff, starting with hovering. That just looks difficult.
It is. It's arguably one of the most challenging basic skills. So a vertical takeoff to a hover, lift straight up, hold heading, Stay perfectly still over a spot just a few feet off the ground.
How's it done?
Controls neutral-ish, maybe cyclic slightly into wind. Slowly, smoothly increase collective. As it gets light on the skids, you'll feel the torque trying to swing the nose.
So you're working the pedals already.
Constantly. And tiny cyclic inputs to stop any drifting forward, back, sideways. You need to come up absolutely vertically.
The source stresses checking control response and CG as you get light. Why so critical?
That slow liftoff is your safety check. If one skid is stuck or the weight's off or control isn't responding right, you feel it before you're fully airborne. You can put it straight back down. If it starts to tilt or roll unexpectedly, collective down immediately.
Makes sense. And once you're at hover height?
Then it's just continuous tiny adjustments to everything. Collective throttle for height, cyclic for position over the ground, pedals for heading. Interestingly, many Heelys hover slightly left side low because of the tail rotor thrust counteracting the main rotor torque.
I can just picture the over-controlling. Push cyclic forward, you dip, add collective, now you need more pedal.
Exactly. It's a feedback loop from hell for beginners. Small, smooth pressure inputs are the key, not big, jerky movements. Anticipate, correct before it moves much.
Common errors on that vertical takeoff.
Drifting instead of going straight up. Yanking the collective, shooting upwards too fast, over-controlling pedals, causing heading swings and RPM fluctuations, chopping the throttle, suddenly big heading change, loss of lift, not being slow and deliberate on the initial lift.
And just holding the hover. What's the technique there?
You're using peripheral vision a lot, sensing tiny changes in attitude or position.
Correct.
Before you see significant movement. Focus your main gaze further out. Use ground references. Don't stare straight down. That leads to chasing corrections.
Right. Focus ahead.
Altitude is collective throttle. Position is cyclic. Heading is pedals. Small, smooth, coordinated. It takes time to develop that feel.
Pitfalls in the hover itself.
Being tense makes reactions jerky. Not allowing for control lag that leads straight to over-controlling. Confusing attitude changes with altitude changes. Hovering too high puts you in the dangerous part of the height-velocity diagram.
Let me get to that, yeah.
Hovering too low risks touchdown. And getting complacent on smooth surfaces, dynamic rollover, is a real danger there.
Okay, hovering turn. Rotating while staying put. Tricky in wind, I assume.
Very. Initiate with pedal in the desired direction. A left turn usually needs a bit more power because the tail rotor works harder.
More pitch on the tail rotor blades.
Right. You use cyclic, often into the wind, to hold your spot over the ground. As you turn, the wind hits you from different angles. Turning into a crosswind needs more pedal and more cyclic into the wind to fight the drift, all while managing altitude and RPM with collective throttle.
And turning downwind must be the toughest part. The weather vane effect.
Absolutely. As the tail comes around into the wind tries to push it further. You have to anticipate and use opposite pedal pressure to control the rate of turn. The horizontal stabilizer can add to this effect too. It requires real finesse.
The source mentioned limits and strong winds, especially turning right for counterclockwise rotors.
Yeah, in a strong wind, the tail rotor might not have enough authority, enough thrust to counteract the weather vaning force for controlled right turn. It just wants to whip around.
So maybe test a left turn first.
Good practice. If a 90-degree left turn feels controllable, a right turn is probably okay. But in really strong winds, hovering turns might just be too risky, especially losing aft cyclic authority when downwind.
Common mistakes in hover turns.
Not keeping the turn rate slow and constant. Drifting off the spot. Jerky pedal inputs. Letting altitude or RPM wander. Not keeping the heli aligned with the direction of travel as you rotate.
Okay, moving while hovering. Forward, sideways, back.
Right. For forward, pick references ahead. Gentle forward cyclic pressure, then ease off to control speed. Cyclic steers the track, pedals keep heading, collective throttle for height RPM, aft cyclic to stop.
Sideways similar, just lateral cyclic.
Yep, reference points to the side. Rearward is the tricky one, limited visibility. Ground guide, strongly recommended. Use forward references. Gentle aft cyclic. Slow speed is key. Maybe hover a bit higher for safety margin.
And stakes here.
Big, jerky cyclic movements are common. Bad pedal control, swinging the nose. Altitude or RPM gets away from you. And for rearward flight, not clearing the area behind you. Critical safety point.
Let's talk taxiing. Different ways helicopters move on or near the ground.
You've got hover taxi, basically low-level hovering, under 25 feet AGL, moving around an airport area.
Like moving between parking spots.
Exactly. Then air taxi flying low, under 100 feet AGL, maybe a bit faster, covering more distance across the airport. Big considerations here. Stay out of the height velocity diagram's bad zones.
The dead man's curves.
Right. And watch out for crosswinds causing loss of tail rotor effectiveness. Avoid overflying people or congested areas.
And surface taxi.
That's mainly for wheeled helicopters. Keep collective down, use cyclic gently for direction, pedals for heading, collective manages speed. Skid helicopters generally avoid at too much risk of dynamic rollover if a skid catches.
Common errors in, say, air taxi.
Erratic cyclic, bad pedal work, letting altitude or PM drift, flying over things you shouldn't, getting into the HV curve, not handling crosswinds well, excessive tail low attitude, using too much power to stop abruptly, not holding the track. For surface taxi, bad cyclic pedal coordination, poor crosswind control, letting RPM droop.
Right, on to takeoffs now. Normal takeoff from a hover first.
Okay, so you're stable in the hover, systems checked, smooth, gradual, forward, cyclic. As you start moving, increase collective to prevent sinking, coordinate throttle pedals, keep it straight down the takeoff path.
Then you hit ETL, effective translational lift.
Right. As airspeed builds, the rotor gets more efficient, you'll feel a lift, maybe the nose pitches up slightly. You adjust collective to climb power, manage the nose attitude with cyclic to accelerate smoothly towards climb speed while climbing safely away from the ground and avoiding those HHV diagram no-go zones.
And crabbing for wind.
Yeah, as speed builds, allow the helicopter to crab into any crosswind to maintain your ground track. Then smoothly apply aft cyclic to establish your normal climb attitude once you have airspeed and altitude.
Pitfalls on hover takeoffs.
Not enough collective early on, sinking before ETL. Too much power without enough forward cyclic climbing vertically instead of accelerating. Getting excessively nose down near the ground, very dangerous. Letting ground track, airspeed, or RPM wander. Forgetting to crab for wind.
And taking off directly from the surface. No hover first.
Often used to minimize downwash, like on dusty ground. Start stationary, collective down, RPM below operating. Clear the area, throttle up to operating RPM. Slow collective raise until it's light on the skids.
Hesitate there.
Yes, pause, check stability, small cyclic pedal adjustments. Then continue collective up, using forward cyclic to start moving as you lift off. Once you hit ETL, it's similar to the hover takeoff transition adjust attitude and power. Sometimes a quick vertical pop is done first just to check power available if obstacles are a concern.
Errors on surface takeoffs.
Getting too nose low initially often needs excessive power. Or too much power with a level attitude can lead to an unwanted vertical climb. Abrupt collective inputs cause RPM and heading issues.
And crosswinds during takeoff. How's that handled?
Initially, you fly in a slip. Use cyclic into the wind to hold your ground track and pedals to keep the nose aligned with the track, tilting the disc into the wind. Once you're up, maybe 50 feet or so, you transition to a coordinated crab, turning slightly into the wind to maintain track more efficiently.
Okay, shifting gears to ground reference maneuvers. These are pure skill builders, right?
Absolutely. They force you to divide attention, control the helicopter, watch the ground references, scan for traffic. Great practice for real-world flying like pipeline patrol. Always do a clearing turn first.
First up, the rectangular course. Flying a box pattern relative to a field.
Goal is constant altitude, constant airspeed, and maintaining the same distance from all four sides of a rectangular area on the ground. Great for learning wind correction. You fly parallel to the boundaries, maybe quarter to half a mile out. Turn abeam the corners.
Okay, let's say you enter downwind, tailwind, higher ground speed. How does that affect the turn?
Good point. Higher ground speed plus the wind trying to push you out of the turn means you need a faster roll in to a steeper bank angle on that first turn. It's usually the steepest turn of the four.
And as you turn crosswind?
You gradually reduce the bank as the tailwind effect lessens. Roll out, establish your crab angle into the wind to track parallel to that side. Then the turn to upwind headwind means lower ground speed.
So, shallower bank. Less than 90 degrees of heading change needed.
Exactly. Medium to shallow bank. Roll out, crab again. You're constantly adjusting bank based on which way the wind is hitting you relative to your track.
Common errors here.
Messing up the entry, poor planning, losing track of where you are relative to the rectangle, uncoordinated controls, not correcting for wind properly on each leg, altitude or airspeed wandering, not having an emergency landing spot picked out, basically not flying a nice crisp rectangle over the ground.
Next, S turns across a road, flying half circles back and forth.
Goal is 2 equal half circles on opposite sides of a straight line, like a road, perpendicular to the wind. Constant altitude.
Starting downwind again.
Typically easiest. Cross the road, immediately roll into your steepest bank because ground speed is highest. Gradually decrease bank through the first half circle. Roll level exactly as you cross the road again, now heading upwind.
Then immediate bank the other way.
Yep, but this bank will be your shallowest because you're now into the headwind, lowest ground speed. Then gradually increase bank through the second half circle, hitting steepest bank just before rolling out as you cross the road downwind again.
And crabbing throughout.
Constantly. Nose point slightly outside the circle on the upwind turn, slightly inside on the downwind turn. Bank angle is always changing based on ground speed.
Mistakes on S-turns.
Trying to steer with pedals, big no-no, slips and skids, making lopsided half circles, bad wind correction, altitude airspeed variations, banking too steeply.
Last ground reference. Turns around a point. Circling a landmark.
Objective. Fly a perfect circle at a constant radius, constant altitude around a specific point on the ground. Bank angle varies, maybe 30, 45 degrees. Great for subconscious control and dividing attention.
Same wind correction principle as S-turns.
Exactly the same. Steeper bank downwind, shallower bank upwind, constantly adjusting to maintain that constant radius over the ground. Nose points progressively inward on the downwind side, progressively outward on the upwind side relative to the point.
Requires very smooth, continuous adjustments.
Very fluid. Pick a good point visible, small enough for precision, away from people, and always know where you'd land in an emergency.
Common errors. Same list mostly.
Pretty much. Bad entry, poor planning, uncoordinated flight, bad wind correction, altitude airspeed issues, varying distance from the point, excessive bank. Practice makes perfect, or at least better.
Okay, let's talk traffic patterns. Keeping things orderly around airports.
Crucial for safety. Standardized flow for approaches and departures. Helicopters and airplanes have different patterns because they fly so differently. Regulations usually say helists should avoid the fixed wing pattern.
Standard airplane pattern is what? Left turns 1,000 feet?
Usually, yeah. Left turns, 1,000 feet above ground level, AGL. Takeoff leg, crosswind, downwind parallel to the runway, base leg, final approach.
And the helicopter pattern.
Typically right turns flown lower, maybe 500 to 1,000 feet AGL, depending on obstacles and traffic. Take off into wind, right turn after 300 feet or so, another right to downwind parallel to take off path at 500 feet. Turn base when the landing spot is about 45 degrees behind you. Start descending to maybe 300 feet AGL, then turn final, considering wind and obstacles.
And communication is key at towered airports.
Absolutely vital. Call ATC, tell them who you are, where you are, what you want to do. They'll often give direct routing. At non-towered fields, stick to the standard heli pattern, avoid the airplane flow, maybe use a separate landing area. Self-announce intentions on the comment frequency.
Right. Now, the approach itself.
Yeah.
Transitioning to land. Approach to a hover first.
Okay, normal approach angle is maybe 7 to 12 degrees Vicent. On final, around 300 feet AGL, get roughly lined up. Precise alignment isn't critical until maybe 50, 100 feet out. Lower collective to start slowing and descending. Aft cyclic helps control airspeed attitude. Pedals for trim.
Visualizing the angle to the spot.
Constantly. Collective controls your rate of descent along that angle. Cyclic controls your rate of closure, your speed towards the spot. As you slow down below ETL, around 25 knots, you lose efficiency.
Need more collective to maintain the angle.
Exactly. Gradually increase collective, maybe use some forward cyclic to keep closing rate steady. As you near hover height, more collective to arrest descent, aft cyclic to stop forward movement, pedals to align heading. Landing, especially hover landing, takes significant power.
Common errors on approach to hover.
Letting RPM droop, using collective wrong, trying to control angle instead of rate, missing pedal corrections for power changes, coming in too fast or holding speed too long instead of decelerating smoothly, not arriving at a stable hover, zero ground speed, correct attitude all at once, low RPM in the transition, too much aft cyclic near the ground tail strike risk, incorrect crab or slip technique in crosswinds.
And the approach direct to the surface, the no hover landing.
Similar approach, but you just continue smoothly to touchdown, often used on loose surfaces like snow or dust. Aim for level skids, zero ground speed, minimal descent rate at touchdown. A final little cushion of collective just as you touch.
Pitfalls there.
Accidentally stopping in a hover first. Touching down with sideways or forward drift. Coming in too fast or too slow. Skids not aligned with direction of travel at touchdown. Huge dynamic rollover risk if they aren't straight.
And crosswinds on approach. Crab, then slip.
Generally, yes. Crab into wind above 5,100 feet to maintain ground track. Below that, transition to a slip, cyclic into wind, opposite pedal to keep the fuselage aligned with the ground track you want to follow. Cyclic controls track, pedals control heading the slip, collective manages power altitude.
Last thing, what if the approach goes wrong? Go around procedure.
Crucial maneuver. If ATC says go around, if there's traffic, if the approach just isn't stable or safe, make a positive decision. First action. Smooth but firm collective increase to take off power. Coordinate throttle and pedals immediately. Establish a climb attitude, get best rate of climb airspeed, and fly away safely to set up again. Don't hesitate.
Wow. That covers an incredible amount of detail on just the fundamentals. It really drives home how dynamic helicopter flight is. Constant coordination.
It really is.
Yeah.
Mastering these basics, understanding how the controls, aerodynamics, and environment all interact, it's absolutely fundamental for safe and effective flying. Even these basic maneuvers require immense skill and focus.
Yeah, absolutely. Considering how sensitive and interconnected everything is on a helicopter, the controls, the forces, it makes you think, doesn't it? What other complex systems, maybe in technology or nature or even society, have similar challenges, where achieving stable, controlled operation is just this constant, delicate balancing act?
That's a fascinating thought. The parallels are definitely there.
Yeah.
Constant adjustment, feedback loops, potential for instability. Yeah, something to chew on.
Definitely food for thought.
Yeah.
Well, thanks for walking us through that intricate dance today.